Okay, let's continue. So, question number 6. If f of x equals x power 5, then the sixth and, there should be here and, then the sixth and the eighth derivative, which are basically f of 6 and f of, or the eighth derivative and sixth derivative of x equals. Basically, we have a rule that says if the derivative is higher than the highest degree in the equation, then the answer shall be 0. So if we have x power 100, for example, and they ask us to find the derivative of 101th of x, then it shall still equal 0 because 101 is still more than 10, or sorry, 100. Same applies in this case. So we see here that f of 6, so here, or the sixth derivative, is higher than 5. Again here, 8 is higher than 5. So the answer for both is 0 and 0. Moving to question number 7. If f of x equals 2 power x plus 1, then find the third derivative and fourth derivative of x. Now we must apply the exponential rule. Why? Because here we have an exponential equation, because we have the x or the variable in the power. Now let's first revise what is the exponential rule. It basically states that if y equals, let's say, 2 power x, for example, okay, then dx over, or yeah, dx over dy equals 2 power x, so we won't do anything, but this time times ln the base, which is at this in this case 2. Okay, we'll do the same thing here. So we'll write the same function again, so 2 power x plus 1, then ln the base, which is 2. Okay, times again, because they asked us for a second and a third derivative, so write times ln 2 again, and again for the third time, times ln 2. This we can simplify it into 2 power x plus 1, so this we brought it down, and then times ln 2 cubed. Here we'll do the same thing. It becomes 2 power x plus 1 times ln 2 4 times, which is basically to the power of 4. Moving to question number 8. If y equals x times 2 to the power of x, and y equals e power x times, let's just here, times 3 power x, then dy over dx. They basically, okay, yeah, I thought there was something wrong with it. It should be dy over dx. Okay, so they basically want us to use the product rule. What is the product rule? You can find it in the other video that I've explained for each of these required skills in the exam. I'll just write it right away. It is basically f times g prime plus g times f prime. Now, these are actually two separated questions. So this is question number 1, and this is question number 2, or you can say this is A and B of question 8. So what is f? This is f in this case, and the second function should be g. And let's start with the first writing the f, which is x, times g prime, which is basically they want us to get the derivative of 2 power x. As we just said, this is an exponential rule, so the derivative of this function would be 2 power x times ln the base, which is 2. So times 2 power x, so we won't touch with the function, but then again times ln 2, plus g, which is 2 power x, and then times f prime, which is what is the derivative of x? So x, the derivative of this will be a constant, which is 1. So times 1. We usually can leave it like this, but we can simplify it more by taking 2 power x as a common factor. So we'll write it here in the bracket outside, 2 power x times x times ln 2 plus 1. Okay, we can move to the second question. Just here, disclosure, if we ever see e power anything, so e power 4, e power 7, e power x, then the derivative of this will still be e power this thing. And I'll show you now why. So again, the power rule, or sorry, the product rule is f times g prime plus g times f prime. This is f and this is g. So what is f? F is e power x times, what is g? G is 3 power x, but they want the derivative of this. So let's apply the exponential rule. So 3 power x times ln 3 is the derivative of this function, or this function actually. So it becomes times 3 power x times ln 3 plus, bring it down, g is 3 power x, and then times the derivative of f is basically e power x ln e, and ln e is basically equal to ln e, or 1, so we don't have to write it. That's why I said it is equal to the same thing. So e power x. Now we can take e power x and 3 power x as common factors, so it becomes e power x times 3 power x, and then the only thing we're left with is ln 3. And this, I think, yeah, this is for question 8. Question 9, basically trigonometry and derivatives. They mixed these two things and they gave us these questions. Now, we have only 3 rules for trigonometry or trigonometric derivatives, which are basically the derivative of sine x is cosine x. Okay, the derivative of cosine x is not sine x but negative sine x, so be careful with this. And then the derivative of tan x is equal to secant square x. After we revise these 3 rules, we can now start with the questions. This is actually a chain rule, and it basically tells us to find the derivative of the outer function and then times it by the derivative of the inner function. So this will become something along the lines of basically sine power x becomes, the derivative of this will be cosine x, over here, x, and then times the derivative of the inner function is still the same, which is e power sine x. So this is for question number 9a. B is basically, this is supposed to be sine x and not 6. So the derivative of sine x we said is cosine x. The derivative of tan x we said is secant square x. And the derivative of cosine x we said is negative sine x. And moving to the last question, which is using the product rule that we use in question number 8, just this time with trigonometric functions. So let's just write the rule right away. So it is f times g prime plus g times f prime. Now this is f, this is g. Let's start solving the question. So what is f? F is tan x, times g prime, which we said is cosine x, and then plus g is sine x, and then times f prime, which is secant square x. Okay, now we can simplify by actually rewriting tan x as sine over cosine x. So cosine and cosine will go together. It becomes sine x plus sine x times secant square x. So we can take sine x as a common factor. It becomes sine x, and then we only have secant square x. But also, if we divide sine x by sine x, becomes 1. So 1 plus, 1 times secant square x. This is the answer for question number 10.